My name is Ning YAO. I'm a master student in computational finance from CCFEA of University of Essex. Now I'm going to introduce my dissertation about the pricing of some power options. It's supervised by Dr. John O'Hara. Here is the agenda of this presentation. Firstly, we may ask, what is power option? Power option is one exotic option whose payoff is depending on a power function of the underlying asset price at maturity. In the financial market, there are mainly two types of power option, the asymmetric one and the symmetric one. We can see the payoff functions in the screen. S is the underlying price at maturity, K is the strike price, and beta is a new parameter. It controls the power in payoff. In the first case, the underlying price is raised to a certain power, while in second place, the payoff of the corresponding vanilla option is raised to a certain power. In both situations, if beta equals 1, the option is exactly the same with the corresponding vanilla one. This dissertation will be all focused on the asymmetric power option and we'll call it standard power option. We can check the payoff structures of standard power options by diagrams. When beta is not equal to 1, power options will have nonlinear payoff structures. Here, its payoff plot is denoted by the blue line and the vanilla option is denoted by the red. If beta is smaller than 1, the payoff is squeezed compared to that of its corresponding vanilla, and is a concave function with respect to the underlying price. On the other hand, if beta is greater than 1, the payoff can be amplified increasingly and is a convex function with respect to the underlying price. The leverage effect increases as the exponent increases. Power options possess unique properties others do not have. Some researchers have showed that the nonlinear payoff structures can be used in hedging nonlinear risks such as interest rate risk, exchange rate risk, and the implied volatility. The enormous leverage effect is ideal for speculators or people who want to seek some enhanced return in relatively narrow price movement intervals. So I believe that the power options have the potential to play a more important role in some certain financial markets. However, this exotic option is still unfamiliar to the majority of people, and the materials on it are very limited. Usually, the power parameter used is bigger than 1. The greater potential payoff and the consequent higher price per contract makes the power option very attractive to both buyers and writers. In the meantime, the high risk and high price per contract can make it less liquid in trading. In the dissertation, I will try to combine power option with some other exotic features to ease this problem and make it more efficient and flexible to use. These are the motivations for me to write this dissertation. In the dissertation, 3 popular valuation approaches will be employed. Closed-form solutions to a standard power option have been given by Essex and Zhang in the publications. Formulas for Greeks can be derived with this pricing formula. As to be illustrated in the analysis of Greeks, the power parameter dominates the risk sensitivities of power options to a large degree. The binomial model can efficiently handle the path-dependent option, like barrier option, and the Monte Carlo method will be applied to deal with the valuation of the correlation option. All computing and programming work involved in this dissertation will be implemented with MATLAB. MATLAB code for each step will be given. So, this dissertation will cover these aspects: the properties and pricing of standard power option, the formulas for its Greeks, and the 3 exotic power options. Specifically, barrier power option and exchange power option will be created and introduced. Here are some references for this topic. If you are interested in it, you can go check these papers or books for a further understanding. Thank you for watching.